So, hello and welcome in this session. So, in this video, we are going to discuss about electric field and how to find electric field due to point charge, due to uniform charged bodies. So, first of all, we will see the effective distance in case of vacuum. What is effective distance in vacuum? We are going to see then electric field, superposition principle, then electric field due to an arc, and electric field due to a ring. So, let us start. In last class, we had seen Coulomb's law of electrostatics, then application of Coulomb's law and force on a charge in a medium, right? So in this case, when suppose medium is not vacuum or air, in that case, due to the relative permittivity of medium, we can write force acting between the two charged particles that will be equals to 1 upon 4 pi epsilon naught. This was for vacuum into epsilon r. The epsilon r is what? Relative permittivity of the medium. So 1 upon 4 pi epsilon r q1 q2 by r square. Now, suppose there are two charged particles. This is one charged particle, this is another charged particle having charge as let us say q1 and q2. Now, in between them, some part is vacuum and some part we have one medium. So now due to this medium, we want to find the net electrostatic force acting between the charged particles. So in this case, how to calculate the force between the charges? So let us see. So in case of vacuum, we know that this is D in vacuum, this is D in medium. So electrostatic force, we know that for vacuum it is equals to 1 upon 4 pi epsilon naught q1 q2 by D in vacuum means separation square. In case of medium, it will become how much? 1 upon 4 pi epsilon naught into epsilon r q1 q2 by separation in that medium square, right? Now, assuming force to be same in the magnitude means what we are trying to find is what should be the effective area, effective separation between the charged particles in a medium so that force will remain same. So, in this case, we can equate the forces if we consider force value of force is same. So, 1 upon 4 pi epsilon naught q1 q2 that will get cancelled and we have dv square that will be equals to epsilon r dm square. If you have confusion, we can write 1 upon 4 pi epsilon naught q1 q2 divided by separation in vacuum square that will be equals to 1 upon 4 pi epsilon naught epsilon r q1 q2 divided by separation in medium square. Now common terms we can cancel and then we can simplify by cross multiplication. So we have separation in vacuum square that is equals to epsilon r into dm square. So from here can I say that separation in vacuum that will be equals to root under epsilon r times dm. Means if I want to replace the medium with vacuum, so we have to replace the separation as root under er, that is relative permittivity into dm. Hope this part is clear to all of you, right? So let us see some questions on this. So here we have two charged particles and this was the separation in which few part was vacuum and some part had medium also, and medium have coefficient of permittivity that is equals to er, relative permittivity. So here now if I want to replace this complete part with one vacuum, so can I say that this part which was vacuum was how much? D minus T, right? And if I want to replace this medium, so we have to replace, we know that D is equals to epsilon r root under into separation of the medium, right? So here medium is how much? T. So T into root under ER. So now we have two charged particles and separation between them is this value. So we can put and we can find the force acting between the two charged particles. Simple, easy. Yes or no? So let us solve one question, then it will be clear to all of you. So question says that two charges Q1 and Q2 are a distance d apart, two mediums of thickness T1 and T2. So I don't know why it is happening. I made this properly. T1 and T2 and their relative permittivity as epsilon 1 and epsilon 2 are introduced as shown. So find the force between the charges. So in this case, the force between the charges will be how much? And again, separation is how much? D. This is charge Q2 and this is charge Q1, right? So in this case, what we have to do is we can find the effective separation and then we can just put the value. So if I replace this complete with a vacuum, so can I say that now total separation was D. So with vacuum separation will be how much? D minus T1 plus T2, the part which is having medium that we have subtracted, right? And when we replace these two mediums, so we have to write separation into root under of epsilon. So T1 root under E1 plus T2 root under E2, right? So now from here we can write force that will be equals to 1 upon 4 pi epsilon naught. We have replaced these two medium with the vacuum. So 1 upon 4 pi epsilon naught only into charges are Q1 and Q2 divided by, now separation is how much? D minus T1 plus T2 plus T1 root under epsilon 1 plus T2 root under epsilon 2, right? And this complete separation square. So this was nothing but D effective we can say, and we can just put the value and simplify if they ask in simplification. Simple, easy, right? Now, so effective distance in vacuum, that will be this value, and then we can find force, that is 1 upon 4 pi epsilon naught Q1 Q2 by effective separation square. So we can simplify if required, otherwise we can leave like this. Now, next is a important topic that is called as electric field. So when we say electric field, what is electric field? So electric field, we can say that when we bring a charged particle and we consider charged particle as the test charge. Why test charge? Otherwise, if we bring one bigger charge particles, then what happens is they will create their own influence. So to avoid those things, what we do is we bring one very small charge particle that is called as test charge near a charge particle, and whatever force they experience divided by charge on this charge particle, test charge, that will give us what? Electric field, right? So in simple word, we can say that electric field in a space surrounding an electric charge in which another charge experiences a force, that force is electrostatic of attraction or repulsion, that we call as what? Electric field. So we can say electric field is region of influence around a charged particle in which if we bring other charged particles, they can experience the electrostatic force. Simple, right? Now how to find that force? So electric field intensity we can write that will be equals to electrostatic force on the test charge divided by magnitude of the test charge. So F by Q naught. Now we know that F is how much? K Q1 Q2 by R square, right? We know F I want to write, so that will be equals to what? K Q into Q naught divided by R square. And if I divide to find electric field, so divide by Q naught, so electric field will be equals to how much? KQ divided by R square. This Q naught will get cancelled, right? So if I want to write in vector form, so we have to write KQ R cap divided by RQ, or R, if I write R cap, so R cap divided by R square, or R vector divided by RQ. E will be equals to KQ R cap divided by R square. Now here R cap is, we consider the charge particle as origin and connect the point where we want to find electric field. That will be the R vector. And here we have to put the charge with sign. If it is positive, then plus Q. If it is negative, then minus Q. That will take care of the direction of electric field. So electric field intensity, also simply called electric field, is nothing but the force experienced on 1 coulomb charge kept in the field. So if I consider this Q naught as 1 coulomb, then force and field, their magnitude will be how much? Same only, right? Easy, simple. Now, next is, suppose that we have 1 point charge and we want to draw a graph between electric field and separation. So electric field is the force experienced on 1 coulomb charge. Value of charge we will be kept along with the sign. Then only we can write. So E is KQR by RQ. Here Q we have to write with sign. If it is positive charge, and plus. If it is negative charge, then minus. That means direction of electric field will get reversed. SI unit. So we know that force electric field, that is equals to force divided by charge. So that is nothing but Newton per coulomb. No need to mug up. Simple. Dimension also we can write. So force is ml t to the power minus 2, and charge is what? I t to the power minus 1, so simplify and you can find the dimension also. If I want to draw graph, so we have E that is equals to kq1 kq by r square, so it is proportional to r square, so graph will be like this, rectangular hyperbola, right? Next, superposition principle, same what we did in case of electric force, electrostatic force. If we have two or more than two charged particles present, like here we have one charged particle as q1, here another charged particle q2, charged particle q3, and so on. So electric field at a point due to n charge is the vector sum of the electric field due to all those individual charges at that point. So I can write net electric field that will be equals to E1 plus E2 plus E3 and so on. So at any point, suppose there are n number of charges and we want to find electric field at a point, net force, net electric field, that will be what? Field due to all the charges, right? Simple. Now let us solve one question. Question says that six identical charges are placed at the corners of a regular hexagon of side A. So net electric field at centroid O will be how much? Net electric field will be how much, right? So here we can write all the charged particles. They are at the all the corners of the regular hexagon. Now, if I want to write electric field due to this charge, let us say this was A, B, C, D, and so on. So, due to A, electric field, since it is positive charge, so away from charge in this direction. Due to D, it will be again along the same line, opposite direction. If charge is same, so magnitude of E and A will be same, so they will cancel each other. Similarly for B and E, similarly for C and F, right? So all these will get cancelled. So here now can I say that E net, that will be equals to E1 plus E2 plus E3 plus E4 plus E5 plus E6. So all in vector sum. So this will be how much? All their magnitudes are equal. So 1, 2, 3, 4, 5, 6. So 1 and 4 they gets cancelled. Similarly 2 and 5, 3 and 6. So net is how much? 0 only, right? Simple, easy. Or if you want to waste time, you can break them in x-axis and y-axis and then add. Again you will get 0 only, right? So electric field at a point due to n charges in the vector sum of the is the vector sum of the electric field due to all these individual charges at that point. So we can write E net, that will be equals to just vector sum, that is how much? 0 only, right? Now, so we can generalize one thing, that is if we have a regular polygon, it can be pentagon, it can be triangle, it can be, this is not regular, sorry. So it can be triangle, it can be a square. So in all these cases, if we have symmetric charges on the vertices or corners, then net electric field will be how much? 0, right? Now, next question. So two particles each having a charge plus q are placed on the two vertices of an equilateral triangle of edge A. So find the magnitude of effective electric field, at third vertices. So here we want to find electric field. So due to both the charges, we know that electric field is what? Vector quantity. So vector, so electric field for first charge, it will be in this direction. And due to second also in this direction, angle between them will be how much? 60 degree. This angle 60, this angle is also how much? 60 degree. So E net will be E1 square plus E2 square plus 2E square cos 60. Separation is same, charge is also same, so E will be same only. So E net will be how much? Root 3 E. Simple, easy question. Whatever questions we discuss, all of you, I will advise that please pause the screen and try to solve by yourself, and after that you can take help of the solution. That is the way to learn physics, right? Because these are all standard questions. You can expect these questions direct in your exam also for JEE Main or NEET, or some questions in JEE Advanced also. So please take care of these things, and let us continue. Next is now let us see continuous charge distribution. So when we say continuous charge distribution, that means what? We have a body on which charge is distributed throughout the body, right? So in this few terms are there. Let us see one by one. First is we call linear charge density. Linear charge density we denote with lambda. So it is considered when the given charge is distributed along a line, along length of a wire. So linear charge density is defined as the amount of charge per unit length. So in this case, if I want to write lambda, so lambda will be what? Total charge divided by total length. Simple. And unit will be what? Charge is coulomb and length is meter. So coulomb per meter. If I want to write a small element, so if I take one small element having thickness as dx, then dq will be how much? Lambda times dx. Simple. Now next is surface charge density. We denote it with sigma. So name itself suggests surface means charge is on the surface of laminar body or any object in which charge is only on the outer surface. So it is considered when given charge is distributed over a surface. Surface charge density is defined as the amount of charge per unit area, right? So suppose Q charge is there and it is distributed throughout the area and total area is A. So I can say that sigma will be equals to total charge divided by total area. Area unit is what? Meter square, right? If I want to write for this small element, so consider a small element having area as dA. So this dq will be how much? Dq will be equals to sigma times dA. That will be charge for this small element. Simple. These are important points. Next will be, can you guess what will be the next point? That is volume charge density, right? So volume charge density we denote with rho. So it is considered when the given charge is distributed over a volume. So volume charge density is defined as the amount of charge per unit volume. So let us say there is one solid sphere in which charge is distributed throughout the volume, everywhere in the sphere. Like suppose one football in which charge is solid football we can consider, or simple words we can say that uh, it is throughout the volume. So in this case, if I want to write charge per unit volume, that is total charge divided by volume. So for a small element, it will be rho times dV. Simple. Now, let us move forward. So now let us see electric field due to continuous charge distribution bodies. So first is we have one uniform rod. So electric field due to continuous charge distribution body. So we have one uniform rod on which charge is distributed throughout the length of the body, and we want to find electric field at this point P. So what we have to do is, now see here, problem is we had the formula E, that is equals to K Q divided by R square, right? But here now if you consider this element, so distance is changing as well as direction is also changing. So for all the points, distance as well as direction both are changing, right? So we cannot say that okay, this is the point from where we have to find the total charge, we can assume. So in this case what we have to do is we can take a small element. So let us say this element has thickness as dx. So due to this element, charge will be how much? Lambda times dx. So now for due to this element, we can write electric field that will be equals to k dq by r square r cap. So k lambda dx by r square r cap. And if some question is asked, they will give you the angle. So from there we can easily replace the r vector and we can find. So electric field will be integration of k lambda dx by r square r cap. Just we have to do the integration. So what are the steps we have to follow? First is find a small element. Find a small element charge, then find dE. What is dE? That is electric field due to that element, and then do the integration. So we can say that E net, that will be equals to integration of dE, and we can find. Simple. These three steps we have to follow whenever we have continuous charge bodies, right? So similarly, if we have a surface charge density, then dq will be how much? Sigma times dA. So due to this element, now we can write dE, that will be equals to k dq is sigma dA divided by separation is r square and r cap is direction, and then we can do the integration to find the net. Similarly for volume also dq is rho dv, so k dq divided by r square r cap, right? Hope it makes sense. It is clear to all of you. Okay. So now let us move forward. Let us say electric field due to an arc. So here we considered one random arc. So consider a circular arc of radius r and uniform charge density lambda. So we have to find the electric field at the center of the circular arc. At this point we want to find the electric field. So again what we have to do? So arc means we can say that charge is distributed along the length of this arc, right? So what we have to do is we can take one small element, and due to that element we can find the electric field. So it is always better to take one random point. If I take this point only, then electric field due to this small element will be downward only. So to avoid confusion, what we do is we take one random point. So due to this random point, let us say this is our random point, and here we have dq. So dq will be how much? So let us say this element, this small element, it subtends an angle of d theta at the center. So angle subtended by this is, let us say, d theta. So what I did is I have taken one small element, and it subtends angle d theta at the center. So dq will be how much? This length will be, can I say this length will be dl, that will be equals to r d theta. Yes or no? So dq, can I write dq will be equals to lambda times dl. dl is nothing but r d theta. This point is important. Once you are able to write a small elements charge, na, then things are very simple, right? So we have dq that is equals to lambda r d theta. So here we have dq that is equals to lambda r d theta. Now for this element, can I say that electric field will be in this direction, dE? So now we can break in two parts. One is in this direction and one is in this direction. Let us say this was at angle of theta from the vertical. So again this angle will be what? Theta. So we have dE cos theta, and this will be dE sin theta. So now see, if I consider one more element at this point, same at angle theta, and the element is d theta, then their component in horizontal direction will be how much? D sin theta, right? So can I say that horizontal components will get cancelled and only d cos theta, vertical component or component along the angle bisector of the curve, that will be the net electric field, right? So in this case, can I say dE due to this element, that will be equals to k dq divided by separation is how much? Radius of the curve r square. So from here now can I say that dE will be equals to k lambda r d theta, k lambda r d theta, r d theta divided by r square. So this square and r we can cancel. So we have now dE that will be equals to k lambda d theta divided by r. Now we know that only cos theta component will get added and sin theta will get cancelled. So can I say that net value? So can I say that net electric field, that will be equals to integration of dE cos theta from where to where? Now limit should be from where to where? So in this case, if I move this side, so this will be how much? Alpha by 2. So can I say it will be, and if I move in this side, so it will be how much? Minus alpha by 2. So when we take limit, it will be how much? Minus alpha by 2 to alpha by 2, right? So now simplify this. So we can write it as E, that will be equals to D is how much? K lambda by r cos theta d theta, integration is minus alpha by 2 to alpha by 2, right? So we know that integration of cos theta is what? Integration of cos theta is sin theta. Integration of cos theta is sin theta. So we can write it as E will be equals to k lambda by r, and sine minus theta is minus sine theta. So minus alpha by 2 to alpha by 2. So they get added and we have electric field that will be equals to k lambda by r. Sorry. So k lambda by r and 2 sine theta. So we can write 2 k lambda by r sine alpha by 2. So this will be our electric field due to the arc at the center. Clear to everyone? Simple, easy. So we can take a small element at angle. This angle is theta at this element. Small element subtends angle d theta at the center. So length will be how much? R d theta. And then we can write dq is lambda r d theta, or it will be k lambda r d theta by r square. So one r we can cancel, and then we can write E will be equals to d cos theta. So E is k lambda by r d theta, and we can simplify. So this will be our answer. Simple, easy, right? Now, in this case, we can generalize that whenever we have a curve and an arc, and we have to find the electric field at the center, so just replace this angle alpha, whatever angle is given, and then we can find for all the elements. So suppose when we have 1/4 of ring, so alpha is how much? Alpha is equals to 90 degree or pi by 2. If you put here pi by 2, that will become how much? 2k lambda by r. So this will become E, we can write as 2 k lambda by r into sine 45, that is how much? 1 by root 2. So if you simplify, this will be our answer, right? If angle is pi, so pi by 2 is what? 90. Sine 90 is how much? 1. So E will be equals to 2 k lambda by r. If angle is 2 pi, so then 2 pi by 2 is what? Pi. So E will be how much? Sine pi is 0. So electric field at the center will be 0. And it's obvious also, when you have a charge ring, then due to all the elements, their net electric field will get cancelled, right? In front of each other, same charge is there, nature is also same, so we can cancel them. Yes or no? But in your exam, what they do is, they will say that half of the ring was having plus lambda charge and rest half is minus lambda. So then we have to do individually. Once first half find electric field, and then due to second half, and then we have to add them, right? Next. So we had seen that when we have an arc and we can find electric field at center for different arcs. Now what about on axis? So when we have one ring and we want to find electric field along the axis of the ring at a distance x. So in this case, electric field will be how much? How to solve, right? So in this case, again our process will be same. We can take one small element. Let us say this element is having charge as dq. So due to this element, now can I say electric field on this will be in this direction, right? dE. Let us say this angle was theta, and let us say this point here we want to find electric field, or at this point. So now due to this element, again if this angle was theta, this angle is also theta. So again we can write d cos theta in horizontal direction, and in vertical direction we have dE sine theta. Now again we can take one more element here, and due to this again the vertical component will get cancelled and we have only horizontal component. Now this distance is how much? D will be how much? D will be, this is x and radius is r, so it will be equals to root under of x square plus r square, right? So we can write dE that will be equals to k dq divided by r square plus x square root under this whole square, right? But only cos theta we have to consider, so we can write as, so here no need to go for dq because we are taking one small element having length as dl. If you simplify, it will be, again become same. So here we have lambda, that is how much? Q upon 2 pi r, right? So q upon 2 pi r. So can I say that dq will be equals to what? lambda into dl, lambda into dl. So this will become how much? Q upon 2 pi r into dl. Now, electric field due to this small element, can I say that dE that will be equals to k dq divided by, why I am doing all these things are so that you can remember it easily. So we have dE that will be equals to k. In your board exams, they may ask you these kind of questions that find the electric field due to charge ring at the axial point. Derivation they can ask. So d that is equals to k dq by r. R is how much in this case? So r we have that is equals to root under of r square plus x square. So it's a square, so it will become how much? R square plus x square. Right? Till this point, any problem? Hope it is clear to everyone. Now, so we consider one small element. Due to that element, we can find d. So now we can write d is kq by r square, which is nothing but kq dq by r square plus x square. Now, if you consider one more element here, so due to that element, this d sin theta component will get cancelled, and we will have only d cos theta element, right? So d sin theta element will cancel out, and we have net electric field that will be equals to integration of dE cos theta, right? So now put the values. So we have d is how much? K dq divided by r square plus x square. This is d part we have written. Now cos theta from this triangle, if you consider, so this length is how much? R. This length is how much? X. And this is our angle theta, and this length is how much? R square plus x square. So if I want to write cos theta, can I say cos theta will be equals to x upon root under of r square plus x square? Yes or no? So put the value. So it will become how much? X divided by root under of r square plus x square. Now see here, in this case r, x, k, all these things are constant. Only variable is how much? dq. So we can write it as integration of dq is what? Total charge q only. So final formula we have that will be equals to k q x divided by, now see here, r square x square, can I say this to the power 1 and this is power half. So it will be how much? R square plus x square to the power 3 by 2. Yes or no? Simple, easy. So net electric field that we have is kqx upon r square plus x square to the power 3 by 2. Now direction of electric field is what? It will be along the axis. Put the value of q with sign and it will take care of the direction, right? If it is positive charge, then away from center, negative charge towards the center, right? Now, one more thing is, now see here, what we have is kqx upon r square plus x square to the power 3 by 2. So here if I put x equals to 0, then we have electric field how much? 0. Now if I put x as infinite, then this term will get cancelled and again we will have electric field at infinite separation, it will be 0 only, right? R square we can neglect if x is infinite, and then again electric field is 0. So at center electric field was 0 and at infinite again electric field becomes 0. That means there will be one point in between where electric field will be maximum. Yes or no? From 0 to some value and then again it becomes 0, right? So uh, for a point far off from the center, x is greater than r, then we have E that will be equals to how much? Kq by x square. So this we can say that the result under the specific condition matches with the electric field due to point charge. So suppose there is one small ring here, charge is q, and we want to find electric field far away at this point. So this radius will become negligible compared to x and it will act as a point charge. And due to point charge, we have electric field that is how much? Kq divided by r square, in this case x square, right? Now let us solve one question. Question is what I was saying, same thing. Find the position along the axis of a uniformly charged ring where the magnitude of the electric field is maximum, and also determine the magnitude of the maximum electric field at its position, right? So what is maximum electric field, that we have to find. So how to find, what we should do? So we have the formula electric field at the axial point, that will be equals to kqx divided by r square plus x square to the power 3 by 2. All of you should be knowing these formulas, as I know it is very important, right? Now, to find any value, suppose you have one function in which one variable is there and we want to find the maximum or minimum value of that function. So what we should do? To find the maxima and minima, their derivative should be equal to what? 0. So can I say that for Emax, for Emax, dE by dx should be equal to 0. Variable is x only here, right? If we change the position of from where we want to find the electric field, right? So simplify now. So let us change the color ones. So now we have dE by dx equal to 0 we have to write. So we can write kq, this is constant only. So d by dx, and we have now, see, if this term can I write as x into r square plus x square to the power minus 3 by 2, u into v format I want to write, so that I can easily differentiate, right? That much mathematics I don't know now. So kq is constant, so right side is 0, so it will become 0. We can move right side. So now we have x, so u into v. What is formula? U into v. Can I say that u into v, if I differentiate, so u du into v plus v into, sorry, u into dv, right? So this will become what? X will become 1. So 1 into r square plus x square to the power minus 3 by 2 plus now x as it is, and this value will become how much? Minus 3 by 2 minus 1. So that will become how much? Minus 5 by 2 into r square plus x square to the power minus 5 by 2. And here now see here, when we differentiate this term, so x square we have, so into 2x, that is equal to 0. Hope it is clear to everyone, right? When you differentiate r square plus x square to the power minus 3 by 2, so substitute method we have to use. We can assume r square plus x square as u or v, and then power minus 3 by 2, and then this part also we have to differentiate, right? Now, so here we can take the r square plus x square to the power minus 3 by 2 as common and move on right side, that will become 0. So now we have 1. Now here minus sign is there. So 1 minus 3 by 2, 3 by 2 and x. So it will become how much? 3 by 2 x square, and 2 is also there. So into 2, right? Into r square plus x square to the power minus 3 by 2 we have taken out, so minus 1. This is equal to how much? 0. So simplify this 2 we can cancel. So now we have 1 minus 3 x square divided by r square plus x square equal to how much? 0. Right? Take LCM. So we have r square plus x square minus 3x square, that is equal to 0. So if you simplify, this will become how much? X will be equals to r by root 2 plus minus r by root 2. Yes or no? So x will be equals to plus minus r by root 2. This will be our final answer. So again, same thing what we have done. So do the differentiation and then simplify. So we have 2x square equals to r square. So x will be equals to plus minus r by root 2. What it says is, from the center of ring, I can choose this point. This distance is how much? R by root 2. Or I can choose this side also now. Here we have minus r by root 2. So at these 2 points, electric field will be maximum and then it will decrease. So suppose if I want to draw the graph, so at center it was 0. So as we move away, it will increase, keep on increasing, and then again it will decrease, it becomes 0, right? On left side, so direction is negative, so again it will increase and then it will decrease, become 0. And this value is what? R by root 2, and this will be how much? Minus R by root 2. Yes or no? Simple, easy, right? And what is maximum value if I want to find? So I can put the value of x in this expression as r by root 2, and I can find the maximum value of electric field along the axis. So if I put the value, you can simplify, simple calculation. So 2kq by 3 root 3 r square, right? Now, let us say electric field due to thin uniformly charged disk at the axis. So when we have a thin uniformly charged disk and we want to find electric field at this axis, so what we have to do is we can take one small element. So in case of disk, a small element will be what? Ring, and due to this ring we can find the electric field at center, and then we have to do the integration to find the net electric field, right? So in this case, derivation I have done separately because these derivations are not that much important, but still if you want to, I will attach that video, you can see. So direct formula we can use, that is E equals to sigma by 2 epsilon naught into 1 minus x by r squared plus x square. Now you may say that this formula looks very odd, how we should remember? So it's very simple, see here. At this point we want to find electric field. Suppose this angle we can say that it is theta, right? So if I want to write cos theta will be how much? X upon root under of r square plus x square, yes or no? So now we can write electric field that will be equals to sigma by 2 epsilon naught into 1 minus cos theta. And just we have to remember theta is what? Angle from this point, from this. So we can write. Simple, easy. Now, so this is all from today's class. Thank you everyone. Bye bye.